Hey there, this is MathCamp321 presenting a short lesson on evaluating derivatives using the calculator. But to start, we're going to actually find the derivative manually, and then I'm going to show you how to do it on the calculator. So there's a few key things that I wanted to note, but I'm going to actually address those once we've gotten started and we move to the calculator. But to start, we're just going to find the derivative manually. So let's take a look at number one. F of x is equal to 3 over the square root of x. In class, we talked about the fact that before we take a derivative, we want to make our function calculus friendly, and there's a few things to keep in mind. The first is that we want to have any variable in the numerator, and we also want to have a clearly identifiable exponent. And right now for this function, neither of those things happen. So I'm going to make a quick adjustment and rewrite this as f of x equals 3 over x to the 1/2 power. In my next step, I'm going to move the variable up to the top, which is going to negate the power, and I'm going to write f of x is equal to 3x to the negative 1/2 power. Okay, and now I'm ready to take the derivative. The variable is in the numerator and there is a clearly identifiable exponent. So I'm going to use the power rule. And in the power rule, the exponent is going to jump down in front and be multiplied by the 3 that's already there. And then the power of x is going to drop by 1 to negative 3/2. So in total, I'm going to have f prime of x is equal to negative 3/2 x to the negative 3/2. Now, we shouldn't leave our final answer with negative exponents, so I'm going to bring the variable back downstairs, making its exponent positive. So I'm going to finish with f prime of x is equal to negative 3 all over 2x to the 3/2 power. Okay, now they want us to find the derivative at the specified value of 4. So I'm going to find f prime of 4, substituting in 4 for every occurrence of x. Okay, now let's deal with that fractional exponent because it might be a little bit scary for some people. I'm going to start with the denominator, which to me is the index of the radical. So this would be thought of as the square root of 4, which is 2, and that result cubed, which is 8, and then 8 times the 2, which is already on the outside, would be 16. So the slope of the tangent line to this curve f of x at the point x equals 4 is negative 3/16. And now I'm going to show you how to do this on the calculator. But before we start, let's go over a few things at the top of the page. The first of which is that you're going to need to enter your function under y1. I think that's pretty obvious. And then if you really want to interact with the graph, you're going to use second trace option 6. If you don't really care about the graph, if that's really not an important aspect of the question, then you're going to enter the function in and you're going to use math8. Now I plan to show you both, and then you can decide for which circumstance you're going to use which method. Okay, so I'm going to start by going to the y equals screen and entering in the function, which is 3 over the square root of x. 3 divided by the square root of x. Okay, we'll do a zoom 6 to look at that graph. Okay, and I want to find the slope of the tangent line at the point x equals 4. So since the graph is right here and the value x equals 4 would actually appear on this graph at the 4th tick mark, I can find the derivative using second trace option 6. Second trace option 6 says dy dx, and that of course is a notation for the derivative. So I'm going to select 6, and at the bottom of the screen it's going to say x equals, and I'm going to put in 4 because that's the specified x value. So x equals 4, and then I'm going to press enter, and it says dy dx is negative 0.1875. Well, it just so happens that negative 0.1875 is the same as negative 3/16. So here's a way to find the derivative of a function using your calculator. Now the other way is to use math8. So again, we would enter the function in under y1, which I've already done. Now I'm going to go to the calculating screen, which is second quit, and I'm going to type in math, option 8, and you're going to see this little structure template set up. And you've got to be able to fill in this template. And you're going to be doing this a lot between now and the AP. So at first it seems very daunting, but it'll become second nature in a few months. So we want to do d dx, the derivative with respect to x, of the function y1, which I'm going to get by pressing vars, yvars, function y1. And I want to take this derivative with respect to the x value of 4. So I put a 4 in there. Now when I press enter, I should get negative 3/16 or negative 0.1875. And I do. Now you'll notice there's a few straggling decimal places way at the end. That's just because of the way that the calculator does this. It might have some sort of rounding issue. But on the AP exam, you're rounding to 3 decimal places. So this would be negative 0.1875 would be completely sufficient. And this 7/4 at the way at the end there wouldn't really make any difference. Okay, so I've given you 2 ways to find the derivative. One, second trace 6, and the other is math 8. We're just going to look at one more example. Okay, the instructions for number 2 are the same. Find the derivative at the specified value of x manually, and then do so using the calculator. So number 2, the function is g of x equals x squared plus 5 times 2x cubed minus x. Now, in order to use the power rule on this function, we're going to need to FOIL to start. And once we FOIL, then it's going to look like a polynomial, and we're just going to go down from term to term using the power rule. So let's start by FOILing. So g of x is going to equal, first would be x squared times 2x cubed, or 2x to the 5th. Outer is going to be x squared times negative x, or negative x cubed. Inner is going to be 5 times 2x cubed, or 10x cubed. And last is going to be 5 times negative x, or negative 5x. Now I notice that there are some like terms, particularly the x cubed terms. So I'm going to be able to simplify this even further, saying g of x is equal to 2x to the 5th plus 9x cubed minus 5x. At this point, I've got 3 terms. The variable in each term is in the numerator, and its exponent is clearly identifiable. So I'm ready to take the derivative and use the power rule 3 times. So my new notation is going to be g prime of x, and using the power rule on the first term, I end up getting 10x to the 4th. Using the power rule for the middle term, I end up getting plus 27x squared. And using the power rule a third time, I conclude with negative 5, or minus 5. Now the problem directs me to find the slope of the tangent line at the specified x value of negative 1. This is going to be notated as g prime of negative 1. And of course what that means is I'm going to substitute every occurrence of x with the value negative 1. And once I evaluate this, we're going to get 10 plus 27 minus 5, which will be 37 minus 5, or 32. So the slope of the tangent line to the graph of g at the point x equals negative 1 is 32. So now we're going to queue up the calculator, and then we're going to enter the function in. If we decide to look at the graph, we're going to use second trace 6. But if we decide not to use the graph, we're going to use math 8. Okay, so I've queued the calculator up. I'm going to go to the y equals screen, and I'm going to use parentheses and type in x squared plus 5, x squared plus 5, times a new set of parentheses, 2x cubed minus x. Okay, I'll start with the zoom 6. And it looks like a wiggle-ish looking thing. And I want to find the derivative, or the slope of the tangent line when x equals negative 1. Now, negative 1 is on this screen. The tick mark negative x equals negative 1 is right there. So to find the derivative, I could use second trace option 6, which is dy dx. It always starts off with x equals 0. You just have to redefine the x value that you want. And we want an x value of negative 1. And then you're going to press enter. And it says the slope of the tangent line is 32. Again, like the last problem, just ignore that 2.9 at the very end there. It's negligible, inconsequential. So the slope of the tangent line is 32, and that's exactly what we got when we did it manually. Okay, now let's pretend that we didn't really care so much about the graph. We just needed to know that derivative without looking at the graph. Well, let's go to the calculating screen, which is second quit, and I'm going to press math and then 8. The math button followed by 8, Actually, let me scroll down to show you what that button even says on it. It says n deriv. So that means take the derivative of. And I'm taking the derivative of a function with respect to x. And the function that I'm taking the derivative of is called y1, which is going to be vars, y-vars, function, y1. And I want to evaluate this function at an x value of -1. Now hopefully when I press enter, we'll see 32. And we do, with that little 29 at the end, which we're going to ignore. So in this quick video, I hope I have conveyed to you how to find the derivative using your calculator, and I've also reviewed with you some of the techniques in finding a derivative manually using the power rule.